As developers, we have all been there. The app works perfectly fine on our machine. Then we move it to another laptop, a staging server, a CI pipeline, or a production. And suddenly something breaks. Different Java version, missing environment variable, wrong configuration, different operating system, maybe some different dependencies. This is exactly the problem Docker helps us solve. Dockerizing a Spring Boot application isn't just about putting your app inside a container. It's about packaging your application, its runtime, and its execution environment in a predictable way. In this video, we're going to look at Dockerizing a Spring Boot app from a developer's perspective. Not just copy this Docker file, but what is actually happening at a high level. When you build a Spring Boot app, you usually think about things like controllers, services, repositories, database, configurations, and APIs. Once your app leaves your machine, another question becomes important. How does this application actually run? Because your Spring Boot app doesn't run by itself. It needs Java. It needs the correct version of Java. It may need environment variable. It may also need profile, database configuration, memory settings. It needs to behave the same way every time it starts. That is where Docker comes in. Docker gives us a way to package the application with the environment needed to run it. Dockerizing a Spring Boot application means creating a Docker image for it. Think of a Docker image as a packaged version of your application. It contains instructions for how the application should run. For a Spring Boot app, that usually means the compile jar, a Java runtime, a working directory, a startup command, expose port, and sometimes additional configurations such as users permission or environment variables. Once we have that image, we can run it as a container. The image is like a blueprint. The containers are the running instance of that blueprint. So as a developer, your goal isn't just to make Docker run the app. Your goal is to create an image that is predictable, portable, and easy to run in different environments. Now you might ask, why not just build a jar and run it directly? And locally, that's totally fine. You can run this command and basically you have your application running. But the problem is that this depends on the machine. Does the machine have Java installed? Is it correct Java version? Are the right environment variables available? Is the app using Spring Profile? Is the operating system configured correctly? When you run directly on a machine, the machine becomes part of your deployment. Docker helps separate the app from the machine. And instead of saying this app works on my laptop, we want to say this app works anywhere Docker can run. That is the developer mindset behind Dockerizing. Before writing a Docker file, it's important to understand two terms, image and container. A Docker image is a package artifact. It is built once, it can be versioned, it can be pushed to a registry, whether we're talking private or a public one. It can be pulled by another machine. A container is what you get when you run that image. For example, you may build one image called Spring Boot app with version 1.0, which is basically our tag. Then you can run multiple containers from the same image, one locally, one in staging, one in production. The image stays the same. The configuration can change depending on where the container runs. That distinction is very important. A good Docker image should not be tightly coupled to one environment. You shouldn't need one image for local, one image for staging, and another image for production. Instead, you build the image once and configure it at runtime. For a Spring Boot application, the Docker image should contain only what is needed to run the application. At runtime, we usually need a Java runtime, the application jar, the command that stores the application, maybe a non-root user, maybe some basic operating system level dependencies if your app actually needs them. But we do not need everything. We don't need the full source code. We don't need Maven in the final image. We don't need the Git history or the IDE files. We don't need to build the local build artifacts from our machine. This is where many Docker files go wrong. They copy too much. They include unnecessary tools. They create large images. They mix the build environments with the runtime environment. As developers, we should separate those two concerns. Building the app is one thing, running the app is another thing. A Spring Boot application has two important phases. First, build time. This is where Maven or Gradle compiles the code, run tests, resolve dependencies, and creates the jar file. Second is runtime. This is where Java runs the already built jar files. These two phases need different tools. At build time, we need Maven or Gradle and a JDK. At runtime, we usually only need a Java runtime and the jar file. So instead of putting everything in one image, we can use a multi-stage Docker build. The first stage is building the application. Second stage, runs the application. This gives us a clear final image. It also means our final runtime image doesn't need Maven, source code, or build tools. That is much better model for production. Another important developer concept is configuration. A common mistake is hard coding environment-specific values into the Docker image. For example, database URL, password, Spring profile, external API URLs, memory settings. These settings shouldn't be baked permanently into the image. So instead, they should be passed when the container starts. For example, this command provides the environment variable needed in order to run this for the production environment. This way, the image stays reusable. The same image can be run in local development, testing, staging, and production. Only the runtime configuration changes. This is one of the most important ideas when Dockerizing applications. Build once, run anywhere, configure at runtime. Spring Boot apps usually run on port 8080. Inside the container, the app may listen on port 8080, but your browser is outside the container. So when you run the container, you map a port from your machine to the container. For example, when you're running this statement, the first 8080 port is the port on your machine. The second 8080 is the port inside the container. So when you visit the localhost 8080, it forwards the request to the port 8080 inside the container. So in the Dockerfile, we can use expose 8080. This doesn't actually publish the port by itself. It documents that the containerized application expects to listen on that port. The actual port mapping happens when we run the container. Another thing developers should think about is logging. In a traditional server setup, you might write logs to files, but in Docker, the preferred approach is usually to write logs to standard output. That means your Spring Boot application logs should appear in the container logs. Then Docker, Kubernetes, or your cloud platform can collect those logs. So instead of thinking, where is my log file inside the container? Think, my app should log to the console, and the container platform will handle log collection. This keeps the container simple. Containers should generally be disposable. If a container dies, you should be able to start a new one from the same image. Now let's talk about security from a developer perspective. A container is isolated, but it is not magic. Bad defaults still matter. One simple improvement is to avoid running the application as a root. Your Spring Boot app doesn't need root permission to serve HTTP requests. So in production-friendly Dockerfile, we can create a dedicated user and run the app using that user. This reduces unnecessary privileges inside the container. It is not the only security step you need, but it is a good default. Good Docker files are not just about making the app start, they are about reducing unnecessary risks. Before we write the Docker file, here is the developer checklist. A good Spring Boot Docker file should use a build stage and a runtime stage. Keep the final image small. Avoid copying unnecessary files. Use Docker layer caching effectively. Run the app with a non-root user. Expose the correct application port. Allow runtime configuration through environment variables. Start the app with a clear entry point. Now that we understand the high-level idea, the Docker file will make much more sense. Here is what a clean Docker file could look like for a Spring Boot application using Maven and Java 21. First stage is building the application. We're making the working directory /app. We're copying the Maven configuration first to improve our dependency caching. Then we're downloading our dependencies in order to use the offline mode. And we're copying the source code, and then we're packaging our application. We're building it through Maven. The second stage is running the application. We're creating a new image from the Eclipse GRE image, and we're making our work directory /app. We're also gonna be creating a non-root user, so we're gonna be creating a new group and a new user. Both of them will be named Spring, and the user will be assigned to this group. Then we're copying only the final jar file from the build stage that we had previously created. And we're taking this jar file, we're setting the ownership of it, and we're running it as a non-root user, which is the Spring user that we had created. And then we're exposing the port, and the entry point in our Docker file is starting our Spring Boot application. We also need to make sure that we don't involve unnecessary files such as targets, get history, so we need to add .dockerignore file. This .dockerignore file will make sure we don't really include the unnecessary files in our Docker image. Now we can build the image through this command, and we can run it using this command with our custom configurations. So Dockerizing a Spring Boot application isn't just about writing a Docker file. It is about understanding how your application moves from the source code to a running service. As a developer, you should think about what is needed to build the app, what is needed to run the app, what should be inside the image, what should be passed at runtime. How do we keep the image small, secure, stable, and predictable? Once you understand those ideas, the Docker file becomes much easier to reason about. You are no longer copying random lines from the internet. You understand what each line is doing. That is the real difference between simply Dockerizing an application and Dockerizing it the right way. If this video helped you understand Docker from a developer perspective, like the video, subscribe, and comment with the next backend topic you want me to cover.